value? What is the S value? What is the X bar?
Standard
So what is X bar?
mean,
Mean. What is S?
standard deviation.
Standard deviation. Square of standard deviation is variance. Square of standard deviation is variance. The S is a measure of what? What does it measure? Standard deviation, what does it measure? Standard deviation, what does it measure? Brian? Brian?
Yes.
Okay, take one hand, open your fingers, close your
Okay.
fingers. Open the fingers, big standard deviation. Close the fingers, small standard deviation. Is that right? Is that right?
Yes. Yeah.
So standard deviation is a measure of spread. Big standard deviation, big spread. Small standard deviation, small spread. Right?
Yeah.
So now we can't compare these two. We square this, then we call it variance. Square this, we call it variance. So these two must be similar. The variances must be similar, right? So that's the assumption. So in testing, you're going to follow this. The test is called Levin's test. Testing of variances, are they similar or different? Same principle, we're going to use p-values. Are the variances equal? Is p-value more than 0.05? Yes. Is the p-value less than 0.05? No. So first, we do this test. This test for testing the assumption. If p-value less than more than 0.05, red line, variance are equal. The red line, p less than 0.05, variances not equal. Variance are equal, we do parametric test. Variance not equal, we do non-parametric test. So in this test, we look at the p-value. P-value more than 0.05 means are equal. P-value less than 0.05 means are different. That's what you want to know. This only if variances are equal. The variance not equal, you do non-parametric test. Again, same. The p-value more than 0.05, scores are equal. We don't use the word mean. And here, p-value less than 0.05, scores are different. So we're going to use this path diagram for all the tests. First, you want to know this. Let's see the example. Okay, example 1. What do you want to know? What do you want to know? What's the objective?
To test if BMI differ between gender.
Gender. What will be age now? Age now means are
BMI equal to
equal.
no.
Equal, right? Age
Yeah.
alternative. Age null, the means are equal. Age alternative. The age null, they're equal. Alternative, not equal, right?
Yeah.
Right. Age null, the means are equal. Age alternative, means are not equal. Right. We do the test. So look at the first table. This is the mean among the females and males. So we describe this. The sample means for females and males are this and this. The standard deviation, you square this, that's a variance. Okay, what's 3.58 square? Let's take 3.5. What is 3.5 square? Calculate. 3.5 square, how much? You understand what square are? 3.5 times 3.5, how much?
12.25.
12.45. Here, 3.2 times 3.2, how much?
10.24.
Okay, we're going to compare the variances. So look at this part. This table, indefensibility test, first part, testing, equal to variance. So here we see, we go to the p-value. This p-value, SIG value is the p-value. Is it more than or less than 0.05?
More than.
More than. That means variances can be assumed equal. So variances assumed equal. What is this part? What is this? What does it say here?
Equality of means.
So here there are two components. Testing variances, square of these variances. Testing means, this I means. Are they similar or different? How much mean difference? How much the difference? Look at this now. How much difference? 7.94. Question is there a big difference or small difference? Look at the p-value. P-value is less than 0.05. So same or different?
Different.
Different. Confidence interval, now you don't have to add. Just take the value, put it down, take the value and put it down. So now, my objective is that the mean BMI between male and female are they equal. So that's my sample values. And that's a mean difference, right? The p-value for test of equality variance is more than 0.05. So now I can use the first row value for p-value for mean difference. That is less than 0.05. Therefore, the means differ. How much they differ? This and this. They differ as much as from here to here. So conclusion, females are heavier compared to males. Is there a difference? Yes. Then who's heavier? Based on this, I know females are heavier than males. Questions? Questions? See, we are using a lot of this term p-value, p-value. Second example. What do you want to know? What do you want to know? Come on, participate. What do you want to know?
Difference in mean age
Mean
between male and females.
Right. So that's the means. You want to know the difference between means? The mean difference 1.7. Right. This is standard deviations. You square them, become variance. So this is testing whether variance are equal. So first write, what is the mean for the male and female? Mean difference how much? And tests are now equality variance. P-value is more than 0.05. Therefore, variance can be assumed equal. So go on the first row. So come to test of equality means. What's the p-value? What's the p-value?
0.096.
More than 0.06, 0.05?
Yes.
That means no difference. I mean the difference is not big. Look at the interval. From negative to positive, right? Negative
Yes.
to positive, isn't it? Where does zero
Yes.
fall? Zero. Inside, outside, zero, value zero. Zero falls inside, outside.
Inside.
Inside means what? There's a possibility that there's no difference. There's a possibility the difference equals zero. That means possibility, no difference. Right? Look at the p-value more than 0.05, no difference. Look at the confidence interval, zero falls inside, there is a difference. Previously, p-value less than 0.05, that's a difference. And the interval from here to here, does zero fall inside? Does zero fall inside?
No.
Zero somewhere outside, right?
Yes.
That means there's no possibility that the means are similar. So whenever the p-value less than 0.05, 0 will not fall inside the interval. Whenever p-value is more than 0.05, 0 will fall within the interval. Questions?
I have a question.
Yeah.
What is the meaning of variance test?
Variance, square this. Square standard deviation is a measure of spread, dispersion. We are asking whether dispersions are they equal, are they similar. Square this and compare these two values. That's why I'm testing here. When the p-value is more than 0.05, we assume the squared form of these two are equal. That's a variance.
Okay.
Take the standard deviation, square it, that's variance. Because the assumption is that the variances must be equal. If not, we cannot use parametric tests. You must use non-parametric tests. The assumption is not met. Look at the third example. What's the objective? What's the objective? Come on, what's the objective? A complete response. What is the objective? What do you want to know?
Mean difference, a difference in mean TG between.
What PG?
TG
Try
between
this
them.
one. Try
Yeah,
this one. Now look at the standard deviation. What is square of 1.9? Almost 2? Almost 4?
Almost 4.
Is it almost 4?
Yes.
Yes. What is the square of 0.7? Roughly 0.7.
0.5.
0.5. 0.5 and 4. Are they very different?
Yes.
That's where the p-value comes in. Now, this test tells you the variances are not equal. So the variances not equal, we cannot use this test. We must do non-parametric test. This test is not valid. That means this p-value, this interval, they are not valid. So you can't use all this because the variances not equal. Then what do you do? We do the non-parametric test. Later we'll do this. We do exactly the same and then get the tables. So take this table. Look at the last p-value there. Is it more than or less than 0.05?
Less than.
Less than. So we do non-parametric test, less than 0.05. We say that's a difference. We don't use the word mean because non-parametric test. Looking at this, the mean for, look at the first table. Which means higher, male or female? Mean rank, which ranks higher, male or female?
Female.
Female.
Females are higher, right? So here, we don't mention means. We go median and interquartile range. How do you do this? We do explore. You put PG here, put gender here, we'll get these values. So now my conclusion, there's a difference, TG levels. We don't say mean TG because non-parametric. So
Okay.
the levels based on this 3.1.65. So TG levels among the females is higher compared to the males, right? So that's what I'm going to do after this. First test this. So guided by this, you must decide parametric or non-parametric. And finally, look at the p-values in the table that comes out. All right, now do this. Do exactly as shown here and do exactly and look at the output. Do now. Okay, look at the output. Are you getting this table? Class, anybody having problem?
Okay.
Okay. It's a descriptive. So first look at the p-value. So we write this first. That's a variance. Are equal. So the p-value means a different. How much difference? The 95% confidence interval. So that's the conclusion. Anybody cannot do this? All right. Try next one. This between the age between male and female. Okay, are you getting all this?
Yes.
Okay. Next. Are you getting this?
Yes.
Right. It means the results were valid. Now do the non-parametric. So follow exactly what is shown here. Okay. Are you getting this table?
Yes.
Okay, what about others? Right. That means there's a difference, but don't use word mean. You're going to find a median and IQR. So do this test. Do this test. Explore. You already done explore earlier. TG and put gender here. Earlier they only use this box. Now you put gender as well. Click OK. Just put TG and gender and click OK. Right. Are you getting this? Ross, are you getting this?
Yes.
All right. Okay. Now you do one more. Test whether the mean SVP does not BMI, right? All right. Test whether mean SBP. Change the age to SBP. Change age to SBP. Okay. Now it's SBP. Okay. What is this value?
One 136.26 for
Okay.
female and 120.18 for male.
All right. What are these values?
The standard deviation is 14.29 for female, 13.12 for male.
Okay. What's the p-value?
The p-value for variant test is 0.51.
5.
So
Are the series equal?
yeah,
Yeah. Now you follow the first row. Come to this p-value.
the p-value is lesser than
How much?
0,
How much is that? Exactly.
smaller than 0.001.
Less than 0.001. That means
That's a difference.
there is a difference. What is this value inside here? What is this value?
It's 10.83 and 21.34.
Right. So what's the conclusion?
The conclusion is the systolic blood pressure for female is higher than male.
Higher than male, yes. The SBP for females higher compared to the males. Finish. Any other questions? Any other questions? Now test one more. TG. Back to TG. Okay, this TG. All right. This is for diabetic or non-diabetic. DM, no DM. Right, TG, same as this. Change this to DM, diabetes mellitus. Okay. This is DM. Okay. So what are the values? This is diabetic, DM, and no DM. What's the mean values? What's the mean TG?
The mean is for diabetic is 3.53
Okay,
and non-diabetic is 2.23.
right. So look at the variance.
It's smaller than 0.001.
Right,
So it's the variance is different.
not equal.
Yeah, not equal.
Then you
Have to
can't
run non-parametric
valid,
test.
then do non-parametric. Same thing. Change this to DM. So instead of gender, change to DM. Okay, look at the results. And the p-value.
Oh ya, makasih.
What's the p-value?
The p-value is lesser than 0.001.
That means
That means it's there's a difference.
there is a difference. That means there is a difference. Right?
Yes.
Next, you do the explore. Do explore. Okay. Okay, do the explore. This TG. This is TM. So what's the value here? So what are the values here? So this will be diabetic and non-diabetic. Okay, what's the value?
The median for diabetic is 2.71 and the interquartile range is 2.24.
Okay.
And for non-diabetic is the median is 1.98, interquartile range is 1.22.
So what's the conclusion?
So there's a difference in TG level between diabetic and non-diabetic patient.
Okay. Who's higher? Who's higher? There's a difference. Who's higher? Diabetic or non-diabetic?
Diabetic.
Diabetic higher.
Yes.
Better non-diabetic. All right. So that's why you follow this particular pathway and you know what to do. Now, how to report all this? Okay, open a Word file. Data. Yeah. Yeah. Okay. Objective is hold on, Okay, draw a table. Draw a table. Four columns and 6 rows. 4 columns and 6 rows. Okay. First variable is a gender, female. Okay, let's start. As we go, fill up. So I'm going to do analysis and fill up the table values. Analyze, compare means, different samples, or SBP, and gender. Fine. 1 and 2. Continue and click OK. Record. So what's the mean value? 136.26. Plus minus 14.20, 2 decimals enough. There's 120.18 plus minus 13.12. Right, t value on the table. Assumption, is it met? The assumption met? Variances?
Yes.
Yes. So what's the t value? 6.09.
09. 8.
Right. 6.0. 6.0.
98.
Right. 3 decimals. 3 decimals. P value. That's a p value less than. P value less than 0.001. Right. Okay, before that, to determine the SVP, so must describe this first. Describe SVP first. Right. There were 800. SVP overall, overall mean SVP. What's overall mean SVP? Okay, for mean SVP. So 129, 128, 169 overall. Plus minus. Plus minus standard deviation 15.0. 8, 9. Right. So this is the first objective, the mean SBP. So mean SBP is this, right? Mean SBP overall. Next, association between demographic characteristics. So these are demographic characteristics. You're going to put all the values. Okay, next, let's say we change gender with, hold on, let me check first. Diabetes. 1, 1, 2. Okay, diabetes. All right. DM. Yes. No. This is 132.30 plus minus 15.98, 125.97, 15.39, 39, 19.998, 15.39. Okay. T value, second table. Assumption, is it met? Assumption, is it met? What's the p value?
0.8.
Huh? Is it more than 0.05?
Yes.
Yes. So what's the p value here? 0.040. And the p value is 0.081. So continue with this for HCl, obese, this factor, okay, obese, okay, complete this table, huh? What are the variables? All right. MC, medical leave, huh? MC, medical leave. Yes. I think it's not only. Right, here only. Okay, fill out this. So clearly mention what's my objective. This table, what's the heading? Let's say table 1. Right. So that's objective. You fill up the table. Fill up. Okay, what's the p-value here? The chloride? Sorry, hypochlorite here. Assumption met. P-value 0.009. Peace. Okay, you fill up all the values. So what's the conclusion? Now you repeat the same thing. Is for DBP. change this to dBp. Objective, mean dBp. Right. Do the same thing, just change the dBp. Okay, table 2. And draw the conclusion. Okay, finish this and take 20 minutes break. 20 minutes break. I'll see you at 5:20 Malaysian time. Okay, see you at 5:20. Don't have to submit this. You don't have to email. Right, just complete.